All right. So what we're going to look at here is how much are these things changing? When you go from 2 to negative 1.5, what happens? You're going down 3.5. When you go from negative 1.5 to negative 5, you go down 3.5. When you go from negative 5 to negative 8.5, you're going down 3.5. And finally, going down 3.5 again. Does that follow that pattern of over 1, up 1, over 1, up 3, over 1, up 5? No, it's always the same. That makes this a slope, and this makes this one a line. Not a quadratic equation. If we look at this one, we are going up how much? Up 8.5. Up 8.5. Up 8.5. Up 8.5. That's always the same. So what does that make this one? Another line. Okay? In order for a table of values to show a quadratic equation, I'll make one that works here. X and Y. Okay? A quadratic function, okay? Some reasons that we can tell, maybe I'll put one more value on here. Okay? A quadratic function has symmetry. So we have some symmetry here because the negative 2 and the 0 are symmetrical. If you're ever wondering, another strategy in these questions is to actually plot the points. So if I do negative 2, negative 1, that would be right there. Negative 1, 0, 1, 0, negative 1, 1, negative 4, and 2, negative 9. Those are the 5 points that we're given. Maybe you can see that this looks like it could be a parabola that's pointing down. This is just an additional example I made up. Okay? The fact that these two here are the same gives me symmetry, which every parabola has. That makes me know for sure it's not a line, because lines don't have that. Okay? Once I look at my numbers, I start to see the 1, the 3, the 5. So that also fits with our parabola. We go over 1, down 1, over 1, down 3, over 1, down 5. So that's a pattern to look for in a quadratic equation. Okay, the one to practice with the table of values in your homework is number 6.